Muchas gracias por estar conectados con nosotros. Thank you, Brian. Thank you for your time. Today we talk about the moon, because this week is the Celebrate to the Moon. Brian Day works at the NASA Solar System Exploration Research Virtual Institute, where he serves in lead position for the lunar and planetary mapping and modeling, citizen science, and outreach. He's a member of the site selection analysis team for the research prospect and lunar mission, one mission of the moon, and is supporting analysis of potential human landing sites on Mars. Brian was the EPO lead for NASA ILCROSS and later lunar missions. Brian has participated in a number of NASA Mars analog file studies, working in extreme environments here on the Earth, and shared some characteristics with Mars. He flew on the Outlook MAC mission to record fragments of common keys entering the Earth's upper atmosphere. Today, thank you, Brian, for the time. Thank you here. Thank you, the other sites. Start.
Buenas tardes. Muchas gracias, Miriam, Pedro, y todos mis amigos en Universum. Gracias a todos ustedes por estar con nosotros hoy. Me llamo Brian Day y trabajo en NASA, en el Instituto Virtual de Investigación y Exploración del Sistema Solar. La Luna es uno de mis temas preferidos para estudiar. Pero primero debo decir que me siento. Hablo solamente un poquito español. Por lo tanto, the rest of my talk will be given in English. So let's advance to the next slide, please. So our understanding of the moon is changing. A new generation of robotic lunar explorers is completely changing the way that we look at the moon. When I was young, when I was a student, I learned of the moon being a completely waterless, completely airless, geologically dead world. But now, because of these robotic lunar explorers, we know that all of that is wrong, and that's very exciting. Next slide, please. We came about this understanding when we started to realize that when sunlight comes and shines on the Earth, or on the moon, when it shines on the equator, it shines straight down. But on the poles, the sunlight comes in horizontally. It comes in flat across the ground. And if there are any craters, the sunlight will come across the rim of the crater and not shine down onto the floor of those craters near the poles of the moon. Therefore, there are craters at the poles of the moon whose floors have not seen sunlight in more than 1 billion years. And we began to realize that if we were going to look for water ice anywhere on the surface of the moon, that would be a very good place to look. Next slide, please. So we got early evidence for water ice from 2 missions back in the 1990s, Clementine and Lunar Prospector. And as they looked at the moon, they gave us evidence that there might be water ice at the north and south poles of the moon. But different people looked at that data in different ways. And some people, when they looked at the data, they said, yes, there's water ice. But other people, when they looked at the data, said, no, we think that's something else. And so we were not sure. Next slide, please. So it came to 2 missions later on, the Lunar Reconnaissance Orbiter and the Lunar Crater Observation and Sensing Satellite, or LCROSS. We depended on these 2 missions to help us understand if, in fact, there really was water ice at the poles of the moon. Next slide, please. And so both of these missions launched together on a big Atlas V rocket on June 18, 2009. And if you were listening that day down there in Mexico, you could have probably heard me in Florida yelling and screaming as the rocket went shooting up into the sky. It was a very exciting day. Next slide, please. So the idea behind LCROSS is actually very simple. The idea was that this robot spacecraft, LCROSS, carried with us the large upper stage of our moon rocket, about the size of a school bus, a mass of 2 tons. And as we got close to the moon, we let go of that big upper stage of our rocket, and we sent it flying down into one of those permanently shadowed craters at the south pole of the moon. It was moving at 2.5 kilometers per second. It slammed into the ground and blasted hundreds of tons of stuff off the floor of that crater, out of the shadows, into the sunlight, high into the sky of the moon. And then our little robot spacecraft dove down into that cloud of stuff, and it sniffed it, it tasted it, it analyzed it to let us know what was there. And that's how we discovered water ice on the moon. This was a fun job. Next slide, please. Here you can see a view from the LCROSS spacecraft looking down into this dark shadow on the moon where the upper stage of our moon rocket hit. And you see that little bright dot in the shadow there. That's the flash from the upper stage of the moon rocket hitting the ground. Next slide, please. And here we can see the cloud of stuff starting to rise up out of the crater Cabeus. It's rising up out of the crater, and that is the cloud of stuff that our little robot spacecraft dove down into to discover water. Next, please. This is the last image that was returned by LCROSS, because the LCROSS spacecraft, after it flew through that debris, it crashed into the crater also. But as it came down close, what you see here, the last image that it showed us, is the crater, the brand new crater that was formed by that upper stage striking the ground. Next slide, please. So here is a graph. This is a spectrum. And what it shows here is a graph of brightness going up and down versus color going left and right. And on this graph we can see a red line, which is what we call a reference spectrum. This is the fingerprint of water. This is the fingerprint of a water molecule. And all those little dips in the line, in that red line, show the signature of water. All the black dots are the data coming from LCROSS. And you'll see that wherever we have a dip in our reference spectrum, wherever the red line goes down, our data goes down. So that shows that we are seeing water. But you will also notice that there are other dips in the data, other places where the black dots go down. That shows that we found other stuff, more than just water. We found other things too. And for years, people will be studying the data from LCROSS, discovering all of the things that we dug up in that crater on the moon. But one of the exciting things is we learned that at the poles of the moon, there are billions of tons of water ice. And that is very important, because if we ever decide to live and work on the moon or elsewhere in space, that will be a very valuable resource for us. Water to drink, water to make hydrogen for fuel, to make oxygen for breathing. This is very important. Next slide, please. So our sister spacecraft, the Lunar Reconnaissance Orbiter, is still in orbit around the moon. And it is making a complete atlas of the surface of the moon. It has many instruments on board. It has a wonderful, wonderful camera that can show us great detail on the surface of the moon. It has a laser altimeter to measure all the ups and downs on the surface of the moon. It can look inside the shadows. It can see inside the shadows. It can measure the temperature on the moon, the radiation on the moon, and it can, with neutron spectrometry, measuring neutrons coming off the moon, it can sniff out where there is water ice on the moon. Next slide, please. One of the things that LRO, the Lunar Reconnaissance Orbiter, has shown us is that these permanently shadowed regions on the moon, these craters that never get sunlight, are the coldest places that we have yet found in the solar system. 248 degrees below zero. This is colder than the daytime side of Pluto. So again, if you're going to look for water ice anywhere, this is a really good place to look. Next slide, please. So one of the things that LRO has showed us is that not only is there ice in those permanently shadowed craters, but there's also ice around those craters, outside of those craters, in areas even where the sunlight sometimes shines. And that ice is located just beneath the ground, only a few centimeters beneath the ground, what we call permafrost. So even in areas that get sunlight, very near the pole, if you dig not too far down, you may be able to find water ice. Next, please. Now, I mentioned that LRO has a wonderful, wonderful camera. And if you look very carefully, what you will see here in this picture, this is a picture of the Apollo 14 landing site where our astronauts landed on the moon. And on the right-hand side there, you see the descent stage of the lunar module. This is what our astronauts rode down to the surface of the moon on. On the left-hand side, you can see an arrow pointing to a little white dot. And that is an instrument package, scientific instruments that were left behind on the surface of the moon by our astronauts. But if you look very, very carefully, between the lunar module and the instrument package, you can see some dark lines along the surface there. Those are the actual footprints of the astronauts. So again, this is a very, very good camera. Next slide, please. So one of the exciting things for you is that you can explore the moon along with us. We have a tool called the Lunar Mapping and Modeling Portal, LMMP. And you can find this on the internet. If you go to lmmp.nasa.gov, you can get data from the Lunar Reconnaissance Orbiter or many of our other spacecraft that have explored the moon. You can explore the moon along with us. Next slide, please. You can use LMMP to measure the diameter of craters. Next slide. You can even use LMMP to measure the height and depth of features on the moon. Next slide, please. You can create 3D views, three-dimensional views of the surface of the moon. And next slide. You can even generate 3D prints of lunar features on the moon. So again, this is available to you at lmmp.nasa.gov. Next slide. And we even have a mobile app. So if you want, you can explore the moon from the comfort of wherever you are, just using your cell phone. It works on Android and it works on Apple iOS. Next slide, please. So, as we look at these wonderful images coming from the Lunar Reconnaissance Orbiter, we see some very interesting things. One of the things we see all over the surface of the moon are big curving cliff faces, big curving cliffs. We call these lobate scarps. And lobate scarps tell a fascinating story of a shrinking moon, of how the moon, when it was younger, it was hotter. But as it cooled, it started to shrink. And as it shrank, its hard outer crust cracked and buckled. And that is what we are seeing here. And when we first started looking at these images, we thought, wow, this is really very interesting. This is telling us something about the very early days of the moon. But then we saw something surprising. We saw how these cliff faces, these lobate scarps, sometimes actually lie on top of nice, clear-looking craters. They actually are occurring on top of these craters. That means that these cliff faces, these lobate scarps, have to be younger than those craters that they are on top of. And what we are starting to realize is that this process isn't something from just long ago. This is something that could still be going on today. Now, this is very different than what I learned in school about the moon being geologically dead. Next slide, please. And we see more evidence of this. Our astronauts left seismometers on the moon that could measure earthquakes. And when we sent our astronauts to the moon, we expected them to encounter what we call moonquakes, earthquakes on the moon. We figured that they might encounter moonquakes from meteoroids slamming into the surface of the moon. We figured that they might encounter deep moonquakes from the gravity of the Earth stretching the moon in tides. Just like we have tides on Earth, there's tides on the moon, with the Earth's gravity stretching the moon. And we also figured that there might be moonquakes caused by rock on the surface expanding, getting bigger during the hot daytime on the moon, and then shrinking during the cold nighttime of the moon. And we saw all three of those types of moonquakes. But then there was a fourth kind of moonquake that we did not expect. It occurs about 20 or 30 kilometers below the surface. It can get up to magnitude 5.5 and can last for over 10 minutes. Now, I have experienced earthquakes in Ciudad, Mexico. I have felt one. I had one wake me up. But it was much less than magnitude 5.5. Many of you have felt earthquakes. Imagine being in a 5.5 earthquake that lasted for 10 minutes. If that happened to you, I can assure you, you would very quickly conclude that the object you're sitting on is not geologically dead. What causes those moonquakes? We don't know. But we're getting some clues. Next slide, please. We're getting some clues from a mission. It's not loading the picture there. but from a mission called GRAIL, the Gravity Recovery and Interior Laboratory. And GRAIL was actually a mission with 2 satellites orbiting the moon together. And what they were able to do is measure the variations in the moon's gravity so that they were able to actually look down inside of the moon. They mapped the interior of the moon much the way LRO is mapping the surface of the moon. Next slide, please. And so what we got was a gravity map of the moon, with here red being areas of high gravity, where gravity is stronger, and blue being areas where gravity is weaker. And from this, we're able to measure things like the thickness of the crust and how broken up the crust is, and look down inside the moon. Next slide, please. As we talk about the geology of the moon, one of the things that it is fun to realize is that there are volcanoes on the moon. What we are looking at here are the Marius Hills. This is taken with the camera on board LRO. And the Marius Hills are some of the most spectacular volcanoes on the surface of the moon. And if you are looking at me, if you are like me, you're looking at this and you're saying, I do not see any spectacular volcanoes there. That doesn't look very good. Well, fortunately, we can use different tools, and LMMP allows us to do this. So let's go to the next slide, and instead of using a camera, we are now using the laser altimeter on board LRO. And as we do that, these cones of these volcanoes now come into view. We can now see the volcanoes. Next slide, please. Now, those volcanoes are actually very small, but if we measure the elevation going across all of those volcanoes, we see something very surprising. We see that all those little volcanic cones are actually sitting on top of a great big, giant, broad shield volcano. So there are giant volcanoes on the moon, but they are very broad, and so sometimes hard to see. But with tools like LMMP, we can bring that out. Next slide, please. So here again, we're going to take a look at the wide-angle view of the volcanoes. Next slide, please. Some of these aren't. I hope you're seeing the pictures. There we go. So now we're looking at what is a gravity map of that same area. So remember we talked about gravity maps, and you can see, again, red is higher amount of gravity, green is lower, and we see this gravity map of the area. Now let's go to the next slide, and we will combine, whoops, back one please, we've gotten ahead, so back one, slide, there we go. So here we are combining the gravity map and the surface map, and what this shows us is the volcanoes on the surface, and then looking down beneath the surface, we can see the big plug of lava that is now solidified, but that has not yet erupted onto the surface. So all of these volcanoes are very old. Next slide, please. We think that most of the volcanoes erupted on the moon between 3.7 and 2.5 billion years ago. A few small amounts of volcanic eruptions might have continued until about 1 billion years ago, but we were convinced that by then things pretty much stopped. But then LRO gave us views of some very interesting areas. This is a view of an area called Ina, and it is very young terrain. We can measure the age by the number of impact craters we see on it, and this is very young terrain. Less than a million, or less than a few tens of millions of years old. And on the moon, that's very, very young. And some people think that this is an area where a volcano may have erupted surprisingly recently. So, again, our thoughts about the moon are changing. Next slide, please. Two more spacecraft that we have orbiting the moon are the Artemis probes. And they are studying how the solar wind, this wind of hydrogen streaming out from the sun, how that interacts with the surface of the sun. Next slide, please. And one of the things that we see is that solar wind is actually blowing material off of the surface of the moon, causing the moon to have a long, almost comet-like tail. And that tail is so long that once every month, as the moon goes around the Earth actually passes through that tail of comet debris, or of moon debris that is blown off by the solar wind. And this may give us some clues as to how the moon's atmosphere formed. Next slide, please. And that's actually a very strange statement I just made, the moon's atmosphere, because again, when I was in school, I grew up learning that the moon has no atmosphere. But it turns out the moon does have an atmosphere. It's a very, very thin atmosphere. It's about as thin as the outermost fringes of the Earth's atmosphere where the International Space Station orbits. And so when our astronauts go out and do a spacewalk at the International Space Station, the atmosphere they experience there at the outermost edge of our atmosphere is about what you would experience on the surface of the moon. But even though it is very thin, it actually is energized by the sun, and it glows. It glows surprisingly brightly. You may have never noticed the bright glow of the atmosphere of the moon, but that's because it's always right next to the big bright moon. If somehow you could remove the moon and leave that atmosphere behind, then from a clear dark sky you'd be able to look up and just with your unaided eye see that glow of the lunar atmosphere. Next slide, please. We call this type of atmosphere an exosphere. And what that means is there's a mechanical difference between the atmosphere on the moon and the atmosphere here on Earth. Here on Earth, the molecules on the atmosphere have their motions. They're dominated by collisions between the molecules. But on the moon, the atmosphere is thin enough that the molecules don't collide. And as they move, they can fly past each other freely. So the motion of the molecules in the moon's atmosphere, it just depends on how much energy they have and the gravity of the moon. Next slide, please. So this type of atmosphere, what we call an exosphere, is an example of what is probably the most common type of atmosphere in our solar system. Mercury has one, the moons of the giant planets have them, our moon, even some of the larger asteroids. This is the most common type of atmosphere in our solar system, but we know very little about it. So we decided to explore it, next slide, with a new mission, a mission called LADEE, the Lunar Atmosphere and Dust Environment Explorer. And it was designed to go into orbit around the moon and then drop down very low and actually fly through the moon's atmosphere, letting us know what the atmosphere's composition was, what it is made out of, and what its structure is, and how it changes over time. This mission was launched on September 6th, 2013, and the mission was completed on April 18th, 2014. Next slide, please. And now I'm going to share with you some pictures of the LADEE mission. This is the LADEE spacecraft being built right here at NASA Ames Research Center in California. Next slide. Once it was done, once it was completed, I hope you're able to see the picture here. I'm not seeing it from this angle, but once it was completed, it was put in a container and put on a big truck and carried all the way across the United States to the Atlantic Ocean. Next slide, please. And here, what I'm hoping you're seeing is a picture of LADEE when it has arrived at a place called Wallops Island. And this is where NASA has one of its launch facilities. This is where LADEE was going to be launched to the moon. Next slide. Here you can, let's go back one slide, please. Here you can see the workers putting LADEE inside the protective nose cone, the protective outer shell of our moon rocket. Next slide. Here we are at the launch pad where our moon rocket is being prepared for launch, and LADEE is in the very top there. Next, please. Here we have a close-up view of the launch pad, and if you look very carefully, you can see two workers standing on the left at the top of the launch pad. So that gives you an idea of how big this rocket is. Next slide, please. And here's a view of our beautiful rocket. It is called a Minotaur 5 rocket, and it is standing there on the coast of Wallops Island getting ready for launch. Next slide. This is on the day of the launch, and the rocket is there at the launch pad, and we were all getting very, very excited at this point because after the sun set, once it got dark, we were going to send our rocket to the moon. Next picture, please. And here's the launch. So the rocket launched, it lit up the sky. It was a spectacular sight. The whole east coast of the United States was clear that night, and people from far down south in the Carolinas to all the way up north in Canada were able to see this rocket launch up into the sky. Next picture, please. It was very, very spectacular. Next picture, please. Here we see it flying over New York City. Next picture, please. Okay, there is a story I have to tell here. When LADEE launched, not far from the launch pad, there was a pond of water. And in that pond of water, there was a frog. Probably not a great choice that that frog made. Because when that rocket ignited, the blast of hot gas coming out of that rocket at supersonic speed hit that pond, and it sent that frog flying. This is a picture from a video. The frog appeared in only one frame of that video. What that tells us is that this frog was moving very, very fast. So that night we actually had two launches. We had a launch of LADEE to the moon, and we had a suborbital launch of a frog. This made all the newspapers, it made Time magazine, it was on the internet, on the TV. We heard a lot about this frog. Next picture, please. So now here, you actually see images of the moon returned by Laddie. So we were very glad to see this as Laddie made it to the moon. And next I will show you something interesting. This is sunrise. So next slide, please. In the next slide, you will see sunrise on the moon. Something that we don't normally see. So that was kind of fun. That was exciting. Our next slide. So we have learned from these missions that there is, again, billions of tons of water ice at the north and south poles of the moon. But what some of the other missions have told us is that there's also small amounts of water mixed in with the soil all the way around the moon, even far from the poles. Small amounts. You would have to dig up an entire football field worth of dirt just to get, less than 1 liter of water. So it's not much, but there's water even in the soil away from the poles. And that's interesting. Next, please. We wonder, where did all of this water come from at the poles and elsewhere? We aren't sure, but we do have some clues. We know that the moon has been hit over and over again by comets for billions of years. And comets are made up largely of ice. So a lot of that ice from the comets could get added to the environment of the moon. We also see that the solar wind is an important feature of the moon's environment. That wind of hydrogen, that hydrogen is moving at very high speeds. And when that hydrogen hits the surface of the moon, it can combine with oxygen in the minerals of the moon. And so you can get the hydrogen and oxygen combining to perhaps form water on the moon. Next slide, please. But what we felt very sure about was that all this water was coming from an outside source. It wasn't coming from within the moon, because our understanding of how the moon formed was from a giant collision 4.5 billion years ago, when a planet about the size of the Earth and a planet about the size of Mars both collided very, very violently. The heavy cores of both of those worlds sank together and formed the big nickel iron core that we have here on Earth today. But some of that outer material got blown out into space and formed a ring around the early Earth. And as material in that ring started to come together, it formed the moon. But because that material was so hot, lighter material like water would have boiled off. And so the moon would have been formed as a very dry object with no water at all. Next slide, please. But then we started learning that perhaps this idea wasn't correct. Our Apollo astronauts brought back with them some beautiful little beads of glass that were erupted from volcanoes on the moon. Fire fountains erupting on the moon. And in these beads of volcanic glass, we found things called lunar melt inclusions, little crystals of olivine. And inside those crystal cases was lunar lava, lunar magma from deep down inside the moon. And because it was inside those little crystal cases, it had been protected from losing any of its material into the vacuum of space. And when we went in with special tools to sample the magma inside these cases, we were surprised to find that in many cases it is rich in water. That surprised us. That does not agree with our understanding of how the moon formed. Next slide, please. As we look around the surface of the moon, we see a number of these what we call pyroclastic deposits, volcanic ash deposits, areas where this volcanic ash has been erupted onto the surface of the moon. Some of those pyroclastic deposits are very, very dry, but some of them have high amounts of water inside of them, as much as 1,500 parts per million. That's similar to what we would find in the soil at the poles of the moon. This is really very interesting. Next slide, please. So now, looking ahead, how are we going to continue our exploration of the moon? We've been sending robot explorers, and we've been having our astronauts in low Earth orbit. But now, we are getting ready for a new spacecraft that will carry a crew of 4 astronauts beyond low Earth orbit, to places like the moon, to asteroids, to Mars. This is called the Orion Multi-Purpose Crew Vehicle, and it consists of 2 main parts: the command module that is made here in the United States, and the service module, which you see on the left. So the command module is that cone-shaped thing on the right, and that's where the astronauts will actually be living. And then on the left is the service module, which is made by the European Space Agency, and that has a lot of the supporting engineering in it. Next slide, please. A new heavy rocket called the Space Launch System will carry the Orion spacecraft into space. There will also be versions of the Space Launch System that will carry large amounts of cargo into space, and that can also be used to carry robotic space probes to very far distant locations far out in the solar system. Next, please. So we are looking forward to the first test flight of Orion and the Space Launch System together. And right now that is scheduled for September of 2018 in a mission called Exploration Mission 1. And this will be an unmanned mission. There will be no people on board, but it will be a test of the system. And what will happen is Orion will fly a loop around the moon and then return to Earth to make sure that everything works. And even though there will be no people on board, we will be carrying a payload of 13 CubeSats. Now, you are probably familiar with CubeSats. You know, a small CubeSat is about 10 centimeters by 10 centimeters by 10 centimeters, and you can grow these together to make, you know, larger CubeSats. But the Agencia Espacial Mexicana is doing some very exciting work with CubeSats, so no doubt you have heard about this technology. So Orion will be carrying 13 CubeSats on this Exploration 1 mission, and 4 of those CubeSats will actually go to the moon. Let's take a closer look at them. Next slide, please. This is an exciting mission called Lunar Flashlight. And Lunar Flashlight will be released when Orion gets near the moon. And once it is released, it will unfold a great big large solar sail. Lunar Flashlight does not have a rocket on board. Instead, it has this big sail. And that sail is Lunar Flashlight's propulsion. It will use the solar wind to sail into an orbit around the poles of the moon. And as it goes around the moon, it will then turn that sail to use it like a big mirror and to shine sunlight down into some of those permanently shadowed craters, to light them up so that instruments on board Lunar Flashlight can look into those craters and see if it can actually see frost, see if it can actually see water ice on the surface of those permanently shadowed craters. This is an exciting mission. Next slide, please. Another CubeSat that will be released is called Lunar Ice Cube. And it is going to look also for water on the moon, but it's not going to just be looking in the permanently shadowed areas. Instead, it's going to be looking all over the surface of the moon, looking for the presence of water and seeing how that changes with latitude, with time of day, with the age of the area that it's looking at. So this is another mission that, again, what we're looking to do is be able to gain a better understanding of this resource of water on the moon. Next, please. Here's another CubeSat called Luna HMAP. It will enter a low polar orbit, and the low point in its orbit will be just over the south pole of the moon. And it uses neutron spectrometers to sniff out where water might be or hydrogen-bearing materials might be. And it doesn't just look on the surface, it's able to look down even beneath the surface. So again, what we're doing here is we're trying to map the distribution of water on the moon. And this is important because as we go to the moon, or as if we go elsewhere, to Mars, to asteroids, wherever, this resource of water ice on the moon could be very important to us. It is very, very, very expensive to carry materials from the Earth with us in space, because the Earth has such a deep gravity well. Getting materials off the surface of the Earth, out of the Earth's gravity, is very difficult, very expensive. But if we can find these critical materials out in space, then it will make it easier for us to live and work in space. Next slide, please. And finally here, amongst those missions, we have the Skyfire CubeSat. Now, Skyfire is not going to go into lunar orbit. Instead, it is just going to fly by the moon as part of its mission. And as it does so, it'll analyze the surface of the moon, do remote sensing, demonstrating technologies that can be useful in the future for studying planetary surfaces and doing site selection, looking for where we might want to land on other worlds. So again, these are all scheduled to fly on the Orion and Space Launch System Exploration 1 mission, or Exploration Mission 1, scheduled to launch right now in September of 2018. Looking even further ahead, next slide please, we have a very exciting mission called the Resource Prospector Mission. This is a proposed mission. The idea is to send a robotic rover to land at one of the poles of the moon. And once there, it will drive around and it will map the distribution of water ice just beneath the surface. And it will have a drill so that it can drill down and retrieve some of that water ice. And it will actually be able to not only recover water from ice beneath the soil, but it will also be able to use an oven and use materials on board to actually create water from the soil of the moon, mix the hydrogen and oxygen together and create water. This whole mission is built around a concept that we call in situ resource utilization, using the resources that you have there. And this applies to the moon, this applies to asteroids, this applies to Mars. The idea is to be able to live off the land. And then one of the coolest things, literally, that Resource Prospector will do, we think that at the end of the mission, we'll have it actually drive into one of those permanently shadowed regions that are so very, very cold and explore what is just beneath the surface there. So it's a very exciting time to be studying the moon. And with the tools that we have provided, we invite you to join us. I look forward to further discussions with our friends at UNAM and at the Agencia Espacial Mexicana. We look forward to many more partnerships between NASA and our friends at Mexico. And please join us in the exploration of our moon. Thank you very much. ¿Tiene usted preguntas?
Yes, Brian. Let's go start with the questions. Tengo en pantalla a los jóvenes del Colegio Carol Board. Seguramente ellos querrán iniciar la sesión de preguntas. Sé que tienen un excelente nivel de inglés.
Hi.
Adelante.
Hello. I would like to know what would be the consequences of taking the water off the moon to bring it back to Earth. So, because the moon is an important way that in which Earth is sustained, but in other aspects like the oceans and all of those things. So, I would be interested in knowing that.
It is a very interesting question. We would probably want to bring water from the moon back to the Earth to study, to understand more about the water on the moon, how it came to be there, and how long ago it came to be there. But we will probably not want to use the water on the moon as a resource here on Earth, because once again, the Earth, we live in a very difficult place. The Earth has a large amount of gravity, and we can be thankful for that because it helps us have a nice livable place here on the Earth. But what that means is getting material to and from the Earth is very, very difficult. So any water that we get from the moon, we will certainly bring some of it here to Earth to study for scientific reasons, but it would be too difficult to use it as a resource, too expensive to use it as a resource, and also the Earth has so much more water than the moon that here on Earth we do not need it as a resource. What we need to do is make sure that we take care of our water here on Earth so that we will continue to have it as a resource. That's a very good question. Thank you.
¿Alguna otra pregunta en el Colegio Carol Board?
Yes, one of my partners wants to know if there is sign of water, is there also sign of lava in the moon, or there are no active volcanoes right now?
We see no active volcanoes on the moon. The closest thing that we may see is that Aina region, which may be a few tens of millions of years old. So we don't think there's any active volcanoes going on the moon right now. But there have been reports of some strange flashes and glows, what we call transient lunar phenomena. And we're getting evidence that these are probably real events. What are they? What is causing them? Quite frankly, we don't know. We are not sure. So the best I can tell you is we do not think that there's any active volcanoes on the moon anymore, but we recognize that there are a lot of things that we do not know about the moon. And so we're going to keep looking, we're going to keep understanding, and we're going to keep being surprised. Great question. Next, please.
¿Alguna última pregunta en esta ronda, Colegio Carol Bor? Colegio Carol Bor, ¿alguna última pregunta en esta ronda?
I have another question that it considers that why does the gravity of the moon is different in some places? Why does it vary the gravity?
That is a wonderful question. That is something that surprised us when we sent our first spacecraft, our first satellites to the moon. And as they would go around the moon, we'd see as they'd be going along, all of a sudden they get pulled harder and then they'd come up. And what we see is that there are areas on the moon where there is a greater density of material just beneath the surface. So areas where there's much more material and then areas where there's less. And what we think is happening is this, that at times in the past, asteroids have hit the moon and have caused giant craters on the surface of the moon. And then magma, lava from deep within the moon would rise up and it would start filling in that hole. And so you would get a dense concentration of stuff where there used to be a hole. Now, not all of those craters filled with a lot of that magma. Some of it happened perhaps later on, and so you had less of a filling. So what we see is that there are areas where there's denser amounts of material and areas where there's less amount of material just beneath the surface. And we call these dense areas, we call them mass cons or mass concentrations. And so we're trying to figure out just exactly how they form, but these concentrations of mass result in higher amounts of gravity. Okay?
Gracias, Colegio Carol Bor. Voy a pasar a Prepa 4. Quiero verificar si en Prepa 4 hay preguntas. Incluso si son en español, podríamos ayudar a traducir para Brian. Si activan su micrófono en Prepa 4.
Un momento, por favor.
Correcto.
Quería preguntar que si los satélites en el espacio tienen sendas solares o cómo se cargan.
This new satellite, this cube satellite, how they take control of their movement. Have they panels, solar panels, or what's the way they control the activity?
Very good question. So the different CubeSats control their motion differently. So as we mentioned, Lunar Flashlight has a solar sail that it uses for propulsion. The Lunar Ice Cube has an ion propulsion system. So it shoots a stream of ions out to move it, to change its position. The Luna H-map has a cold gas propulsion system, so it's just got essentially compressed gas that it squirts out to use to move its position. And the Skyfire CubeSat uses something called electrospray propulsion. So it charges drops of liquid and sends them shooting out because of this electric acceleration. So you put an electric field in front of a charged liquid, and you can send a spray of charged drops out at high velocity. So different propulsion methods. All of these, though, do have solar panels to be able to get electrical power to do all of this. Outstanding question. Thank you.
¿Alguna otra pregunta en Prepa 4?
Yes. ¿Qué pasaría si la Luna de repente cambiara su órbita?
¿Podrían repetir, perdón?
¿Qué pasaría si de repente cambiara de dirección la órbita de la Luna?
Brian, the moon is changing the orbit, but what happened is if this movement was high, what happened if the moon changed drastically their orbit?
Okay, that's a very interesting question. One of the things that our moon does for us with its orbit around it that it has now is it helps to keep the Earth's orientation fairly constant, so it doesn't roll over on its side, so we don't have very extreme changes in the seasons. One of the things that we see on Mars is because Mars has two moons that are very, very, very small, and they have not done a good job of stabilizing Mars that way, and so you've had much more what we call polar wander. And so Mars's environment has changed very much more dramatically over time for that reason and for some other reasons too. But the moon helps stabilize the position of the Earth, and that's an important role that it plays.
¿Alguna última pregunta en esta ronda, Prepa 4?
Sí, quería preguntar qué pasaría si la Luna cambiara de dirección hacia su lado oscuro.
Brian, if the moon changed the orbit, could we see the dark side of the moon?
Yeah, so that's an interesting question too. So because of the tides between the Earth and the moon has become locked with us so that we only see one side of the moon. That means its rotation is the same as its revolution. They both take the same amount of time. So as the moon's orbit changes over time, we expect that gravitational locking will still remain in place. You would have to do something very violent to the moon to get that to change. So really the only way that you're going to see the far side of the moon is by spacecraft that can go out there and give us a view from a different angle.
Gracias. Vamos aquí a Universum.
Brian, what is the
Yes.
new results about the LRO missions? What is the new results?
The new results of the missions?
Yeah.
So the spectacular results from LCROSS is of course that we have so much water ice on the moon. That's not what we expected. The results from the LADI mission are that we have a number of different gases in the moon's atmosphere, and they behave differently. They actually behave as if they're separate atmospheres. For instance, helium in the moon's atmosphere stays in the atmosphere day and night. But argon in the moon's atmosphere stays up high during the daytime, but at night it settles down and lies on the ground. And then as you have sunrise, the ground heats up and the argon rises up again, and you get an argon wind across the surface of the moon. We also see that certain elements, such as sodium, their concentration changes over time. And one of the things that helps them, or that is related to this change, seems to be meteor showers. So when there's a meteor shower, we see higher amounts of sodium, and then it drops back down, and then you have another meteor shower, and the amount of sodium goes up. So we're learning more and more about the moon all the time. One of the things that we're learning from, of course, LRO is we're learning about the temperature on the moon. We're learning about the radiation environment of the moon. We're learning about the landforms on the moon. We're learning about where we would like to go back and see more of on the moon. Grail is giving us this new view of the interior of the moon. We realize that the moon is not quite like what we thought it was, that the moon's crust is very fractured. It is broken up. And we also learned that its thickness is a little bit different than what we were thinking. So we originally had thought that we've learned from Grail, we've learned that the moon's crust ranges from about 34 to 43 kilometers in depth. And that's 10 to 20 kilometers thinner than we had previously thought. So we're getting more and more information back from the moon from these probes. And the more things that we send out there, the more missions we send to the moon, the more we're going to learn. I am reminded back during LCROSS by our chief scientist, a gentleman named Dr. Tony Koloprit. And as the mission was progressing, a reporter asked him, "What do you expect? What do you expect?" And he said, "I expect to be surprised." I thought that was a wonderful answer. So as we send more and more missions to the moon, we can expect more and more surprises.
Okay, we have another question.
So we can actually see the glowing atmosphere of the moon from the Earth, or we need to be out of the space?
Yeah, so there are ways that you can actually, you'd use just a small telescope, but with very special filters. Researchers in Boston have been able to come up with these telescopes that can see the glow of the moon's atmosphere from here on Earth. And so that is very exciting. So you can't just look up typically with your eye and see it, because, again, you've got the glow from the bright surface of the moon. But if you block out that surface and you use a special filter that allows you to see the light that's given off by the atoms in the moon's atmosphere, then yes, you can actually take pictures. In fact, one of the pictures that we had, if we were to back up when we first started about the glow of the moon's atmosphere, that picture that you saw of the moon's atmosphere, that was taken from here on Earth. So yes, you don't have to go to space. The moon's atmosphere was actually discovered from here on the surface of the Earth.
Thank you, Brian. I want to talk to ask about these last missions you mentioned. Are they international collaborated missions? Is there any possibility to Agencia Espacial Mexicana participate in these missions?
So that's an excellent question, and more what we are seeing is that as we do this exploration, we're going to see more and more international cooperation. So just as on the Orion spacecraft, we have, the European Space Agency is building the service module on that. As we look at the Resource Prospector mission, we are now talking with international partners that can help us on that. We are seeing this is a real pattern going into the future, that as we do these missions, we're going to see more and more international cooperation. And I know I've just heard that there's cooperation between the Agencia Espacial Mexicana and NASA in doing a number of ventures. And here at sservi, at this institute where I work, we are very much looking forward. We've had some preliminary talks, and we look forward to extending those talks to more partnerships between our institute and Mexico. So yes, there are opportunities, and there will be many more opportunities. We look forward to working with you. Excellent question, Pedro.
Thank you, Brian. Vamos a la última ronda de preguntas. Regreso con Colegio Carol Bohr. Quiero verificar si en Carol Bohr hay alguna última pregunta.
We don't have questions, but we need to go, so thank you very much.
Thank you.
Lo mismo para Prepa 4. Quiero verificar si hay alguna última pregunta o comentario. Si nos activan micrófono en Prepa 4. Parece que no tenemos.
Thank you.
Correcto, no tenemos preguntas en Prepa 4. The last question is here in Universum, Brian.
Very good.
Okay. Hi, it's my turn. Okay, once I read about the temperatures of the solar system, so I found that the coldest temperature is the south pole of the moon. Is this right?
So we're still getting data back from the New Horizons spacecraft that recently flew by Pluto. But yes, we know that the temperatures that we have measured in these very dark, permanently shadowed areas on the moon are extremely cold and are colder than what we have found even on the daytime side of Pluto, and maybe certainly among the coldest places we have measured anywhere in the solar system. One difference is that as you look at the surface of Pluto, of course it's spinning, you have day and night, and so areas there will sometimes get sun and then it'll get dark, but then it goes from day to night. So that's why Pluto might have some additional warmth over some of these areas that have been in complete shadow for billions of years. So yes, the moon's permanently shadowed regions appear to be, if not the coldest, at least among the coldest places we have seen anywhere in the solar system.
Brian, thanks a lot for your help. Thanks a lot for the session. Please tell Ashcon it was a great collaboration. And only we have to tell you some words from Miriam, ¿no?
Gracias, Brian, por tu tiempo y qué bueno que participaste en la Semana de la Luna nuevamente. Espero que nos visites para que también puedas tocar aquí la luna.
De nada. Muchas gracias. Muchas gracias a todos ustedes.
Gracias Brian, gracias Ashkan. Nos vemos en la conferencia de marzo. See you in the next video conference.
Very good. I look forward to that. Thank you.
Goodbye. Goodbye. And
Bye.
Ashkan, thanks a lot again.
And we're out.